teachers and students. We've been talking about the water molecule and its polarity and how that allows it to do some very amazing things. How we can put many drops of water onto the surface of only one penny, or sink many paper clips into a glass that's completely full of water. And how a water strider insect can walk on the surface of a pond or creek. And last experiment, how you were able to float a paper clip in water. We're going to do another experiment now that involves the polarity of water, but this time we're going to use milk. For this, you're going to need a pan, a little bit of milk, some food coloring, and some dish detergent. The first thing you'll do is pour the milk into the pan, just enough to cover the bottom of the pan. Next, we're going to add just a drop or two of food coloring. I'm going to do one of each color. There's our blue, there's our green, there's some red, and lastly I'll put in a drop of yellow. And you'll notice that it's not doing much. Let it sit for about 5 minutes. Don't stir it, but just observe how those drops of food color begin to spread. My last one is the smallest, my first one is growing a bit, and it is now the largest. But just watch them for about 5 minutes. You can pause the video at this time. As you can see, not much has happened. The food coloring does not seem to want to mix much with the milk for some reason. And it has to do with the same thing that causes a water skipper to be able to walk on the surface of the water. It's the polarity of the water. Our food coloring is made with water. And milk has water in it too, but it also has something else. It has oils in it, or fats. But watch what happens when I add a little bit of dish detergent. Now you can see that things have started to happen. The colors are moving around inside the milk. Why would that be? So why is this happening? Why is it the food coloring didn't tend to mix with the milk until I added some soap to it, and then it mixed quite well? Well, again, it comes back to what we talked about earlier. The same reason that that water skipper can walk on the surface of the water. It has to do with the surface tension of the water because of the polarity of the water molecule causes it to stick together. Well, milk, although it's made of water, also has oil in it and fats. And you may have heard oil and water don't mix. If you take a glass and fill it half full of oil and half full of water, shake it up with a cap on it, of course. After you set it down, those two will separate again. Oil and water don't mix very well, and it has to do with the polarity of the water. However, once I put soap into the milk, one of the things that soap does is it breaks down fats and oils. In fact, that's why we wash our hands with soap. Is it breaks down any grease or oil that's gotten on our hands and causes it to go away and rinse off with water. Without that soap, rinsing your hands with water won't get oil and grease off of them. Try it sometime. Put a little oil on your hand, run it under water, bring it back, still oily. Put some soap on it, rub it around, rinse it, the oil is gone. So what the oil does is what the soap does is break down the oils and fats in the milk, and then the food coloring can mix with it. The two chemicals are compatible. So I hope you enjoyed watching this experiment, or perhaps even doing it yourself. And until we meet again, happy science.